Today we get to solve equations using subtraction. So let's take a look at the problems that we'll end up seeing. So we have a few problems that are just general problems that ask us to solve an equation that's already set up for us. And then we're also going to check our answer to make sure we're doing it correctly. And so when we look at an equation, we want to solve for the unknown, q in this case. And when we solve an equation, we use opposite operations, because what we're going to end up doing is try to eliminate this plus 12. And so the opposite of plus 12 is subtract 12. So if I do that, those 12s cancel out, so I'm just left with q. But in order to keep this in balance, I need to make sure I do the same thing on the other side. So I'm going to take away 12 from both sides of this equation. So what I'm left with is q equals 7. So how do I know this is right? Well, I can check by taking this 7 and substituting it back in for q. So I've got 7 plus 12 equals 19. And if 7 and 12 do add to make 19, which they do, then I know I did it correctly. So q is 7. Let's take a look at the next one. Here we have a number in front of the variable. Same sort of thing though. It's a positive 34. So I'm going to end up taking 34 away from both sides. And that's why I'm solving by subtracting in this case. So now I have this f that I bring down. I do the subtraction, make sure I borrow from the 4, change it to a 3. So this is 13 take away 4, which makes 9. Well, I can check my answer by substituting. Put that 9 back in for f here, and now I have 34 plus 9 equals 43. Well, sure enough, 34 and 9 do equal 43, so I know I did it correctly. So that is our answer. Last of this type, here we've got 52 on the left-hand side that we're going to take away. Again, we take it away because it's a positive 52. If you see no sign in front, that means it's a positive, and so that's why we're subtracting. So now I have this w equals, no borrowing here, I'm left with 16. Well, let's just double check and make sure we did that right. 52 plus 16 should equal 68. So we go ahead and add those numbers. 6 and 2 do make 8. 5 and 1 do make 6. And those two numbers agree. So that means, yes, we did it correctly. Well, now we have some word problems. And so what we're going to want to do is write an equation to make these match. And so let's take a look at our first one here. Kenya bought 28 beads. Nancy bought 25 beads. It takes 35 beads to make a necklace. Write and solve an addition equation. We have to do two addition equations to find out how many more beads they each need to make a necklace. So many more. How many more beads do they need? Well, let's see what Kenya's equation would look like. And so her equation, got to get an n in there, so let's fix that real quick. So Kenya's equation, well, she starts with 28 beads, so let's write that number down, 28 beads. And now she needs to make more, because they're asking how many more does she need. So how many more? Well, that means we're going to add a number of beads. We don't know how many beads, so let's go ahead and use a variable like b for beads. And so this is the amount that she needs extra. And then this equals the total number that she needs. So this is the extra she needs, extra beads. And then we also have the total that she needs is 35. That's what it says. It takes 35 beads to make a necklace. So this is the total needed. And so once we've got our problem set up, now we can go ahead and solve. And so all we're going to do is a subtraction problem here. So we're going to take away that 28 from both sides. And we're left with b equals, got to borrow a bit, change this to a 2. 15 minus 8 makes 7, so Kenya's going to need 7 beads. Well, let's take a look at the next person, Nancy. Nancy has how many beads to start with? Well, she only has 25 beads, so we start with 25. Well, she needs more beads than 25 because it takes 35 to make the necklace. So we're going to do 25 plus b, and then this will equal the total of 35. And so from that point, we're going to go ahead and subtract that 25 from all sides. And so when I take away the 25, I end up with b equals, and then I get 10. So 10 beads is what she needed. Well, here it talks about during a sales trip, Mr. Jones drove 15 miles east from Brownsville to Carlton. So let's go ahead and do this. Let's draw a little picture about what's going on. Brownsville to Carlton. So we'll draw a little dot and a C to Carlton. And that was 15 miles. So 15 miles there. Then he drove several more miles. Several more. Do we know how many? No, we don't know. So this is going to be our variable. We're going to have a variable m there. So she drove several more miles, don't know how far, from Carlton, which is where the 15 miles was, the first stop, to Brownsville. So actually, I'm sorry, to Sun City. Brownsville is where we started. So Sun City. And so the distance from Brownsville, all the way to Sun City, was 35 miles. So we want to find out how far is it from Carlton to Sun City. Well, we know that the total is 35, and that's what we had over here. We were always setting this equal to a total on these problems. So we're going to start with the 15, just like we started with 28 beads for Kenya, and then we added the unknown number of beads to equal the total. Same thing here. We're starting with 15 miles. We have a number of miles, so we fix that. Instead of an equal sign, I'm going to put a plus. We're going to add some extra miles because we drove further. So we don't know how many miles, so that's why I put the variable m. And the total number of miles is 35. So now I've got my equation set up. So to solve, I'm just doing a subtraction problem, subtracting 15 from all sides. And that gives me m at 20. So it's 20 miles from Carlton to Sun City. Taking a look at our next one, Emma paid $26 in all. So that tells us right there that we're dealing with the total. So remember what we're doing. On these problems, we always have a starting point, and then plus an unknown equals a total. That's kind of our formula that we've been doing these last few times. So we have a starting point, and then we add on an unknown. And then once we have that unknown and the starting point added together, that equals a total. So that's what we've done on the last three problems. And this problem's not any different. Well, actually, the last two. And this problem is going to be the same way. So it says Emma bought in all $26 a hammer and a screwdriver. The hammer cost $10. Okay, that's our starting point. And we have an unknown. We don't know how much the screwdriver costs. We're going to use a variable n to show that amount. So an unknown, but we know it was $26 in all. And so if we wanted to solve this, all we'd have to do is subtract the $10. Subtract the hammer's amount from the total amount, and that gives us the screwdriver's amount. $16 for a screwdriver. Must be a nice screwdriver. Well, here Alice bought a round-trip ticket to fly from Baltimore to Chicago. So Baltimore. Here's Baltimore, and we're going to Chicago, okay? And it looks like the fare, this is not distance now, it costs $250 to go from Baltimore to Chicago. That was $16 more than she would have paid on Jet Airlines, which only offered a one-way fare. How much did Jet Airlines charge to go from the same city to Chicago, so from Baltimore to Chicago? So we're going to start similar problem, a little bit different though. We have a starting point, and so our starting point is the amount that we know. So starting point is the $250. But this one's different because they paid $16 more than she would have paid. So we don't know how much she paid. So this is our unknown. But instead of plus the unknown, we're going to take away the unknown. So let's call it n equals not a total, but a difference this time. So this one's a little bit different because it's a difference that we're going to be given here, 16. See, on all the others we were given totals. But because we're given a difference, that means we have a subtraction sign between them. So to solve this, it's a couple extra steps. So what I'm going to do first is subtract that 250. Now, whenever you subtract and put a bigger number on the bottom, you got to rewrite it. Make sure you put the smaller number on the bottom so that you can borrow. And so when we do the subtraction, we end up with 234. So 234. And the other thing about this problem is it's negative. It's a negative 234 because I'm taking away more than what I started with. So from that point, From that point, what we're going to end up doing is we're going to end up having to divide by this negative. So I'm going to divide by -1 on both sides. And so when I do that, I end up with n equals 234. So now I have $234, and that's the cost on the one-way airfare on Jet Airlines. Let's take a look at our next one here. Together, Ken, Judy, Sam, and Allie worked a total of 83 hours last week. And then it said Allie worked, so a total of 83 hours. You might need that number in just a moment. Ken worked 3 more hours than Judy. So let's write this down. Ken equals, and then 3 more hours than Judy. So we're going to do Judy's time plus 3 hours. That's Ken's time, because that's what it says, 3 more hours than Judy. Allie, she worked 5 more than Ken. Well, Ken is J plus 3, so let's use that. So this is our A here for Allie. Allie is J plus 3, that's Ken's time, plus an extra 5 hours, because she worked 5 more hours than Ken. Well, Judy, she worked 4 more hours than Sam, so Sam's time plus 4. And then it says in the last sentence that they give us, it says Sam worked 15 hours. Oh, they give us Sam's amount. Sam equals 15. So they want to know, how many hours did Ken, Judy, and Allie each work? Well, let's just substitute. Let's put this 15 in place of that S. So Judy equals 15 plus 4, which equals 19. That is Judy's amount right there. And so let's do the next one. Now we take that 19, we're going to put it in for Judy's amount to find Allie and Ken's. So let's do Ken's first. Ken equals the 19 hours that Judy worked plus 3 extra, because it said he worked 3 more than Judy. And so that's going to give me 22 hours. So that is Ken's amount. And then the last one, Allie. Well, Allie worked Ken's amount, which was J plus 3, so we know that was 22, plus an extra 5 hours. So we add those numbers up, and that gives us 27, and that was Allie's amount. So we wrote an expression for each of the unknowns, and then once we got to that final sentence, they told us, or the second to last, they told us what Sam's amount was, and we were able to substitute that amount and then substitute further to be able to find the others. Well, those are the types of problems you're going to see on tonight's homework. Good luck.